Hi, everybody. Thank you so much for joining us today on the GCP Online Meetup. We're here to bring you episode 55. This is the follow-up to our Streaming 101 session that we did a couple of months ago. As always, I am Yuri Grinstein, Customer Engineer at Google.
Hi, I'm Michel Sarandar, Customer Engineer at Google as well. I'm really excited by this subject, streaming and data. Yeah.
Thank you so much for being here, Michel. And we are honored to have Vince Gonzalez from the Big Data Specialist team join us today. Vince, thank you so much for being here.
Yeah, my pleasure. Thanks for having me on.
Yeah, man. And maybe you could start by telling us what is a Big Data Specialist?
Well, we're just like you, except we really have a limited scope of the things that we have to know about and remember when we go and talk to people. So my specialization is big data and analytics. So I mostly deal with the GCP products that are part of that big data stack.
All right, very cool. And since you are coming to us from New York City, where I imagine the weather is less than ideal, I dressed up for you, so I'm wearing my hat, trying to stay warm.
I just have the California way.
Yeah, exactly. Whereas Michel is representing California to the fullest. So again, thanks for being here. So when we first did our initial session on streaming, we had talked about sort of the basics of like why you might do data streaming and how streaming is different than batch processing.
Yes.
Right. And I'm really excited to have you on today to basically take that discussion to the next level, right? So we talked about all the products that make up a streaming data pipeline, but I believe you have something really cool to show us today, which basically takes what we did in our first session to the next level.
Yeah. So I hope it's useful for people to see what we'll talk about today. I have, I've been doing some additional learning, trying to continue to advance my learning in streaming and Apache Beam, and in doing that, you're always kind of looking for interesting data sets that kind of bring use cases to life a little bit. And one of the ones that I found interesting was the fact that there's actually a number of ways that you can get streaming data about aircraft that are actually in the sky flying around right now, which is a really great source because it's, we're always looking for real data that has interesting characteristics. And the nice thing about aircraft is that it's something that's easy to have a mental model about. Everybody understands the basics of what a plane is doing, right? It takes off, it flies around a little bit, and then it lands. And in between, it gains altitude, it operates at different speeds, and there's different kinds of aircraft, right? And so if you have access to this data that on a streaming basis, it's kind of interesting to be able to watch the stream as it's coming in. And then there's also a lot of streaming concepts that you get to play around with on actual real data, which is very cool.
So yeah, I mean, that sounds cool to me.
Yeah. And it's really real because planes just fly over the ocean. There are some mountains, so it must be is definitely really close to what another type of stream could bring on the table. So yeah, that's a really good example.
Absolutely. So Vince, how do we get data about a plane?
Yeah, so I made a few slides to sort of set all this up. So I'll switch over to that and we'll take a look. So I want to give credit to my colleague Sean Madej, who provided me with this great slide. There's a number of ways that planes can be tracked, and the one we're going to talk about today is ADS-B. I should have written down what that stands for because I can't remember exactly what the acronym is. It's
just assume A stands for aircraft, and it doesn't really matter.
One would hope, but the point is ADS-B is radio based, and so we've now got planes flying around in the air that are fitted with these radios that are constantly transmitting interesting information about themselves. So you get a unique identifier called the ICAO. You get, if you're lucky, you get things like GPS position, you get their speed, current altitude, and a bunch of other data points that you can use. And these things, as I say, are transmitted by radio. So all you need in order to listen to this stream is some kind of a radio that is able to actually tap into this and then turn it into data. And so one of the ways that you can do this is with a Raspberry Pi single board computer, right? So I think probably everybody, if you're interested in streaming data, you probably know what a Raspberry Pi is. But these things are super useful, and there's kits you can buy. that come with a few other components. So we take a Raspberry Pi, we put it in a little case, we buy a software-defined radio that plugs into one of the USB ports, we buy an antenna that plugs into the software-defined radio, and we've got something to power the whole setup with. And there are software that you can download that'll actually drive the software-defined radio, so you can tap into that signal that's coming from those aircraft. And this is another slide from Sean, and Sean actually has worked on doing this with his Raspberry Pi, and then emitting data into Cloud PubSub, which is a great example of IoT, right? You have a little Raspberry Pi that's out there emitting data into Cloud PubSub, which then might trigger some kind of a cloud function, serverless computing and all that. And the thing the cloud function might do is actually just take that data that came in from the radio and write it into a NoSQL data store like Cloud Data Store.
Yeah, awesome. So this is like so a little different than the one-on-one example that we used, where we actually had an App Engine app emitting events, sending them to PubSub, being picked up by Dataflow, and then writing them to BigQuery. Your pipeline is a little different, but the same general idea still applies, right? You need a thing that's emitting events, which in this case is your Raspberry Pi as it captures data from the aircraft.
Mm-hmm.
Then you need sort of your transport layer, which is PubSub. Then you may need to do some processing on it, which could be Cloud Functions, could be Dataflow, and then you need basically like the thing where the data is going. And in this example, it's Data Store, but obviously it could be Bigtable or BigQuery.
Yeah,
Yeah, exactly right.
Just one thing. So guys, if you want to ask questions as well, so I will be monitoring the live chat. So any question you want to add, just you can add. So I will just make sure that it's answered during the session.
Absolutely. Please send questions for Vince.
Yeah.
All right. So we got the general idea. Show us what you're going to do next.
Yeah. So I mean, once we've got these Raspberry Pi trackers built, it is interesting to publish this data to PubSub and consume it on your own for your own interest. But at some point, you might be interested in actually seeing what's going on in more than just the little pinhole that your antenna might see in the sky above your home or your office or whatever. And so there exists a handful of places where you can download some software, add it to your Pi, and then the data that your software-defined radio picks up can be transmitted to a place where it's aggregated for all the world to see. And one of the places that does this is ADSB Exchange, and ADSB Exchange is really great. I'm actually using it to consume data in real time, and so that's what we're doing. So they've got basically large numbers of enthusiasts out there who've built something like these Raspberry Pi rigs that then watch the sky. They feed data back to ADSB Exchange, and then ADSB Exchange makes it available back to the public. It's free for hobbyists like me to use, but if you are wanting to use their data for commercial purposes, then it's probably a good idea to reach out to them and comply with their licensing policy. They're really nice guys. I reached out to them, and they gave me permission to use their data for this talk. So thank you for that, ADSB Exchange guys.
Awesome. Little props to ADSB Exchange. So I think you just said something that's really interesting that we should probably emphasize is like a single Raspberry Pi with a software-defined radio is going to be able to see some very small subset of the sky above, right? Like I don't know what the range on that is, but we're probably talking a couple miles at most.
What's interesting is just to break in there. Apologies. What's interesting is that depending on line of sight and where you actually position the antenna, you can see for hundreds of miles.
Oh wow!
And so these radio signals don't really do well penetrating buildings and so forth. So for that reason, I actually, and my setup in my house actually has a pinhole view of the sky because it's in my basement and sees just a tiny little piece of sky, and so I really only see the planes going nearby me to the nearby airports. But if it were up on my roof, or if I lived out in the plains of Oklahoma or something, I might see much more of the sky and get a view of many more planes.
All right, so now we've got thousands of these setups, all gathering data, all sending them to ADSB Exchange. What can you do with it?
Well, let's see. So I put together a scrappy little demo here, and hopefully you can see that now. It's scrappy because it is basically a map with some colored lines on it. And then I'm actually using the developers console to provide additional UI here. That's part of my UI is the log messages going through the developer console because I'm front end challenged. But
I love it.
what this is doing is actually watching all of the planes that are flying around right now over a little piece of the sky here in the Northeast. So you can see on the map that we're looking at an area a little bit east of Philadelphia, out toward the ocean, and the yellow lines represent flights that are currently being tracked. So when we think about the way that these receivers are getting their data, you've got a receiver somewhere at some point on the Earth, and there's planes flying overhead. The receiver is only going to see certain planes for a certain amount of time, and so we're using
Sorry,
this.
I think we just had a bad connection for a second. The last thing we heard you say was planes flying overhead.
Okay, so the planes are flying overhead. There's a receiver on the ground listening to those radio messages, and while we're tracking a flight, we color the line yellow. You'll see some red marks periodically around. And while once a plane is no longer being tracked, that there's no receiver on the ground that is seeing it any longer, we turn that line to red. And so this is the way in which we're sort of visualizing the different kinds of windowing semantics available in Apache Beam. So what I'm doing here is I'm actually tracking a flight, but I'm using the sessioning capability in Apache Beam to accumulate a bunch of these signals from these ground-based systems. And yes,
can you drill down into the windowing? So why using session? Why not using, for example, a fixed window or any other type of windowing?
Yeah, thanks. That's a good question. The session windows are a good fit here because you can think of this almost like a user activity. So if I'm doing something like wiggling a mouse around on the screen, I could consider that my mouse activity a session. So while I'm transmitting information about the position of my mouse, I can say that all of the positions for that mouse over a period of time, bounded by some inactivity period, is my session. So maybe I move my mouse around for 3 seconds and that generates a whole bunch of points. And then once I haven't moved my mouse around for a couple of seconds, I'm going to close out that session and then emit the result of all those points that I moved around. A fixed window would be fine here as well, I suppose. But the session windows, I think, fit the mental model of a plane flying around. We uniquely identify each aircraft. That's the key. And then the positions of the aircraft as it transmits them down to the radio are the things that we actually want to track in the session. So those would be akin to the points of my mouse moving around. And so the latitude and longitude points are what comprise the session. And then once I haven't seen a plane for, I think it's a couple of minutes that I have it set to, I actually close out the session and then emit something like a final result, an aggregation of all of the points. But in windowing, what sometimes we want to do is we don't always want to wait until the session is closed before we emit a result. And so what we do in Beam is we set up what are called triggers to say that to govern the behavior around what we want to do when we believe that we have only some of the data that we'll see. Govern what we do once we believe we've seen all the data, and then also to govern what we do once we see data that we didn't expect or data that arrived late.
Nice.
Okay. So you introduced a couple of really interesting concepts there, sort of the concept of sessions or windows, right, which is the time frame during which you're receiving data, at the end of which you're going to emit sort of the aggregated data. And then this idea of triggers, which are things that are happening during your session that may tell you that things are happening, something is going on that you need to take action on further. And both of those are things that you're going to show us how you've implemented in Apache Beam, which is the programming paradigm used to do streaming data processing in Google Cloud Data Flow. But before the data that we're working with, gets to data flow to be processed, can you show us like what that pipeline actually looks like?
Yeah. So let's see. Right. So first, I guess I'll show you what the architecture for this thing kind of looks like, right? So we've got ADSB Exchange, which is out there collecting up all of this data and making it available for people like me to use. And I've got a GCP project, and in it I have a compute engine virtual machine, which is running a little Python script that receives that data from ADSB Exchange and then republishes it into Cloud PubSub. Then I've got a data flow pipeline, which does a number of things in it, and we'll go into some of the detail on what it actually does. But once it's done doing its thing, it writes out a bunch of different results to a bunch of different data stores. So we write results to our operational store, which is Cloud Bigtable, which is actually what is backing the UI that you're looking at. So the events are flowing in real time. The pipeline is processing them and then performing some aggregations over the data. The thing that we actually calculate that the UI uses is an encoded polyline, which is a way that you can encode a whole bunch of latitude and longitude points into a string so that it's easy to pass around, and that's what we're using to drive the Google Maps API. And then we're also writing out to an analytics store and an archival store. The analytics store being BigQuery, so I can actually query over the data using SQL. We do that on an event-by-event basis. And we write all of the raw events out to an efficient archive and cloud storage as well. We're using Avro formatted files on cloud storage. We're not going to go into either of those two things on the outside, but this is, I think, also again a pretty typical pattern that you see. Right, you'll get your data from somewhere in the streaming sense. You'll often get it from Cloud PubSub. You'll process it maybe with data flow, and then write it to one or more storage sinks, and then interact with the data via one of those sinks.
Very cool. And obviously makes a lot of sense. And I think now we're starting to get into like the real topic that we're here to discuss, which is your data flow pipeline, right? We want to talk about some of those advanced topics, some of the things you just introduced, like sessions, windows, and triggers. Let's dig into it. Show us the good stuff.
Yeah. So we talked about this a little bit before. Yellow lines are what we're actively tracking. Red lines are no longer tracked, and arrows denote the direction of flight for the most part. Sometimes they get turned around. Not quite sure why, but you know, these things will happen. What's driving all of this is a big data flow pipeline, and so you can see we've got a moderately interesting graph here. And if we look at this sort of from the topmost box and then work our way down through these paths. So we start out with this pubsubio.read, which is where we're getting our data from after it's been pushed in by that compute engine instance. We've pushed in this data as JSON, so we extract it. The JSON strings from the PubSub messages. The PubSub messages are just a bag of bytes, so we pull that out and make some sense of it as a JSON payload, and then we convert that JSON into an ADSB, what I'm calling an ADSB record. An ADSB record is just a Java object that is built from an Avro schema that I've provided that matches the JSON schema. One of the things that you'll see written up sometimes as a best practice is to use an efficient encoding when you're passing data through the pipeline. So as we move from step to step in a streaming pipeline, if we go from JSON to Avro, we actually cut down the amount of data that we actually have to ship between stages in the pipeline and between nodes in the pipeline. And this is overall a beneficial thing to do. And so that's what that JSON to ADSB record means. We're actually converting JSON to Avro in that step. To the left, we write to our BigQuery rows. Down the middle here, when the JSON to ADSB record goes to the right, where we start filtering our records. So we actually filter out the records that don't include latitude and longitude information. There are some records that come through this way that only include the aircraft identifier, which is only marginally useful for our use case. So I just go ahead and get rid of those at that step. After I filter, sorry, was there a question?
Yeah.
Go ahead.
It's just so that's data flow is wonderful. I really like seeing a pipeline like this one. Just one question regarding language. So what language did you use, and how easy to start with data flow to create this type of pipelines?
Yeah, so I wrote the pipeline in Java. I'm using the Java SDK for Beam. How easy is it to start? I think it depends on where you come from. I think if you have a strong Java background, then that's a good thing. If you are also familiar with other sort of high level um, data pipeline type programming constructs, things like Spark, things like Apex, Apache Crunch, scalding. These sorts of things are useful if you have experience in that, and even MapReduce honestly is a useful background to have here. Where people tend to find it easy. I think the people who tend to find it difficult are the people who are less comfortable with Java or aren't don't have much experience with the big data space. For me, I think I fell down somewhere in the middle. I was comfortable with the big data space, but not quite as comfortable with Java coming in. So I had to do a lot of remediation on my Java skills to really feel comfortable in Beam. And now that I've done that, I get to do amazing things like make pipelines like this. So I highly recommend if you're looking to get started with it, exploring Java, getting shaking off the rust on your Java skills is worthwhile.
All right, so now I think we understand kind of the basics of what the pipeline is doing. Let's get one level deeper right now. Since we're talking about Java, show us the code.
Let's look at some code. So one of the things we often want to do in a streaming pipeline. Oh, are you guys with me? I saw a little blink on the
Rob, but we're back with you, and we are looking at a screen called enrichment.
Excellent. Okay. So one of the things we often want to do in a streaming pipeline is enrich the data as it comes in. So in the case of this ADS-B data, what we're getting is pretty raw information. We get this ICAO number, which uniquely identifies an aircraft, and then we get a bunch of latitude, longitude, other positional telemetry type information. What we want to do is actually be able to take that ICAO number and match it against something. And so all countries around the world have aircraft registries. The United States has one. It's called the FAA. The FAA keeps a database of all the aircraft that have been registered. And you can download that database. And so that's what I did. I downloaded the database. Comes in a text delimited format, and I loaded it into BigQuery. And what I'm doing in this snippet of code here is really just prior to this snippet of code, I actually executed a BigQuery query that just gets back the information I'm interested in enriching with. I turn that into a Java map, and then based on the key in the data that I'm getting from in the ADS-B record, the key being the ICAO number, I can match that against the FAA database in order to get information about the aircraft that's flying overhead. And so if there's a match, I go ahead and update my ADS-B record with additional information, thus enriching it with information from another database. And so this is a pretty common thing to want to do. And you can see where this is happening inside of the pipeline in the picture on the left, right? I've got the ICAO keyed record, and then I enrich the record with FAA data. That represents the merging of these two things. And so in Apache Beam, there's a few ways to do joins. The way I'm doing the join here is with what's called a side input. You generally will choose a side input if your data that you want to use is pretty small. If it'll fit in memory on one of the workers is usually the principle that you want to keep in mind there. And so since this database of all these FAA registration records is only about 200 megabytes in size, I figure let's use it as a side input, keep it in memory, distribute it to all the workers. Dataflow and Beam will automatically do that for you. So you say side input, and Beam will work with the runner. In this case, it's Cloud Dataflow to provide that data out to all the workers. And so that's how the enrichment is working. And the rubber really kind of meets the road on that in that little highlighted portion where we're doing the map, working with the map.
Vince, side question on side inputs. Imagine that the data for a side input was not stable and where the data is just changing all the time. What would you recommend?
It's possible to It's possible to use an external service. So sometimes what people will do is represent that data through some kind of an external service with an API. Within a parallel do, one of the sort of fundamental building blocks of Beam, you can basically do anything you want. And one of the things you can certainly do is call out to external services if that's what your use case calls for.
And because data flow is totally distributed and it could just be thousands of nodes, is it definitely something that it's so my question is, I definitely wanted to make a point that the workers can be totally distributed, and this data is going to be sent to all the workers, so you don't have to think about the data.
So I think Michel's question is, does data flow or Beam more properly manage the distribution of your data across all of its workers, or is there any sort of manual, is there need to do any of that manually in your code?
Yeah, that's a good question. So the answer is no. There's no need to do manual distribution of data to workers. Part of the point of Beam and the programming model is that you should be able to express your pipeline in a very high level way, and not worry about the low level concerns like actually shipping data around to different workers and how much to give each. That process is part of what the Beam model does is take your pipeline, translate it to some sort of language independent representation, and then send that down to what's called a runner. In my case, I'm using Cloud Dataflow, but your runner could also be Apache Spark, Apache Flink, Apache Apex. And so it's really up to the runner exactly how they facilitate that. But thankfully, that's not something the developer needs to concern themselves with.
All right, cool. Thank you. All right, so now that we've covered kind of our first advanced stream processing topic, which is enrichment, let's move on to what else you're doing in your pipeline.
Yeah, so the next thing we're doing is what I'm calling here sessionization, and this is the thing where we are taking these the records that are coming in from these radios, and then bunching them into groups based on the aircraft and a series of messages that we've received. And so you can see the code on the right-hand side. So the first thing we do in order to window over data is usually we want to window by the event time. And what we mean by event time is as opposed to the time that the piece of data arrived at our system for processing, we want to actually process the data based on the time that the event occurred. And so one of the things that we will often see in these pipelines is that we have to extract the timestamp from the event itself in order to have that considered for the windowing function. And so that's what we're doing in that first apply invocation, where it says apply event timestamp. We're extracting the timestamp from the event and then passing that through the pipeline. In the next step, we're actually we're defining our window. So we want to create session-based windows. So what we're doing here is we're saying that we want sessions with a gap duration of 2 minutes, which means that we want to include in any session data that is keyed we want to include any data for a key until you don't see that key again for 2 minutes. The next thing we're doing is actually creating some triggers. And so what we're doing next, after we've defined our window, is we're saying when we want our results to be emitted. And what we're saying here is that we want to trigger after the watermark and past end of window, meaning that after we have all of the data, we want to emit all of the results. We also want to emit early. So what I'm saying here is I want early firings as soon as I have 3 elements. That's what after paying element count at least 3 is doing. So since it takes 2 points to make a line, I said figure we'll do 3, make it a party, and then you can actually render a line on the screen once you've got 3 points. And so as soon as we see 3 points from any aircraft within a session, we'll go ahead and run that through the pipeline and create some flight tracks, which can then be rendered on the screen.
So that makes a lot of sense, right? You probably don't want to start collecting and representing data from every time you get a data point, because there could be airplanes that come into a range of a receiver and then leave, and then you never see them again. And if you try to represent every single one of those on your map, it's going to be a mess.
You have a lot of little tiny dots, yeah, and so that's part of why that's there, is just to make sure that we get a few lines showing up on the map.
So that makes a lot of sense, and that's a great example of why you might choose to use a window and sessions and triggers, is to do these kinds of things, is to basically make sure that you have the data that you want before you write it out and eventually represent it.
Exactly.
All right, very cool. What's next?
So moving on, a couple of little tidbits here before we sort of well, actually, you know what? Let me back up for 1 second. I think there was something I forgot to say. So after we define our trigger, there's a couple of other things that we usually want to do. We want to say sometimes that we want to allow for late data, and so in this pipeline, what I'm saying is I want to allow lateness of up to 2 minutes here. 2 minutes is just a static variable that I defined previously, so that is all that is. But this lets me say that I want to emit all the data once I think I've got all of it, but then I also want to leave open the possibility that data may arrive after I thought I already had all the data. And a lot of times what people do when they build systems to deal with streaming data is they'll sort of come up with their own heuristics to manage this. They'll just have artificial delays built in, and so on and so forth. And the triggering mechanism, the allowed lateness mechanism here, makes it very easy to specify exactly the behavior that you want when data arrives late, and be sure that you're getting correct results. The correct results part comes in when you say how you want the late data refinements to be transmitted. So in this case, I'm discarding the fired panes, which only means that I'm just going to emit the deltas from what came before. So rather than holding on to all of that position data for that extra 2 minutes, I go ahead and toss away the pane as soon as the watermark passes. And if any additional data comes in late, then I'll just send out a new track with just the data points that came in late, and those will get plotted separately.
Vince, you talked about watermark. Can you drill a little bit on this one?
Only a little bit, I think. It's watermarks are essentially the measure that Dataflow has and Beam has of estimating the completeness of the data in the pipeline. So there are some really great talks out there on YouTube that I highly recommend by some of our software engineers. Slava Cherniak did a talk at Strata, I think, a couple of years ago. He went on talked only about watermarks for about 40 minutes. So there's quite a lot of depth to the topic, and I don't think I would do it justice in a couple of minutes here. So would highly recommend those talks for a deeper dive.
All right, fair enough. Let's move on. Let's keep going.
Yeah. So, I mean, I hope that was a useful introduction to something like to what I think is a fairly interesting pipeline with a fairly interesting data set. There's a couple other things I wanted to point out about the pipeline here. So, one of the things that's great about using a pipeline like this is that we're actually doing a lot of processing, but along the way, we're aggregating our data. By aggregating the data, we actually reduce the amount of data that we need to store someplace. And in cloud, where you basically pay for what you use, reducing your data is generally a good thing for cost, right? So in this case, you can see the part that I've highlighted in red. We've got 24 million or so input elements being added at a size of about 3 gigabytes. The output collections, you'll see the elements added are much smaller, and that's because what we're outputting is actually the result of the aggregation of a large number of data points. And because the next things that happen are actually getting us ready to write out to another system, in this case to Bigtable, that the fact that we're writing less data is actually good. That means that I get to run a smaller Bigtable cluster. So that's another thing to think about when you are coming up with your schemes for aggregating your data, for windowing it, and for triggering. You can think about how you want to manage your cost by imposing certain kinds of restrictions on the data in your aggregations as it flows through the pipeline.
Yeah, and it's actually a great example of how you can, sort of aggregate based on the requirements that you're trying to deliver on. So like the visualization that you build is basically, lines of the flight path, right?
Mm-hmm.
Yeah, you're not trying to represent every single data point that you saw from that plane, right? You're sort of drawing lines to show where the plane is flying. And to do that, you can often like extrapolate, right? You can, especially for things that don't turn very fast, right? An airplane is probably not going to make sort of pinpoint, turns on a dime. So you can be fairly confident that you can have an extrapolation over a mile or two without really losing a lot of your data fidelity. And just like you've now shown us, it can actually save you a lot in terms of data processing and data storage costs.
In my experience, there is another side experience on this as well. So you talked about BigQuery. So and the aggregation of the data through data flow helps the analytics as well. As soon as you start understanding what type of aggregation is going to be helpful for visualization or further analytics, to be able to reduce the size of the storage or to accelerate the analytics using data flow is also a really, really good use case.
Yeah, makes sense. Very cool. All right. So speaking of costs, like, obviously this pipeline is running. How do you have a sense of like how much data is flowing through it and how fast things are happening and how healthy is it?
Well, the data flow UI gives you actually a lot of information. So you'll see errors surfaced right there in the UI. You'll be able to drill down into exactly the log messages that are causing those error messages to bubble up. You can actually go and also look at the exceptions themselves to see the exact line in your code where maybe things are going wrong. You also get a large number of metrics. Some of these, like you see on this slide, right, the input collections and output collections are a good way to get a sense of how things are flowing through the pipeline. You also get good measures like the system lag. You can see that because I'm running the data flow pipeline on a relatively small number of runners, that I've got a system lag of about 11 minutes. That's a good thing to know is how far behind real time you actually are in these real time pipelines. And with Dataflow, you have the ability to add additional workers or even let the system scale up and down automatically for you. Other runners will have potentially other capabilities in this regard as well. In terms of knowing exactly how things are going, metrics are really great. One of the things you can do in Beam as well is define your own custom metrics, and you can see a few of the custom metrics that I added here just to show. When I'm for instance, decoding JSON into these ADSB records, you can see that I've got something like almost 55 million successful translations of JSON into these ADSB records, but 8 times it failed. One thing that's useful to do is sometimes to have what we call side outputs, which will take these bad records and then write them out to some place where they can be examined. This is a good way to find bugs in your pipeline and also to make sure that you don't drop bad records on the floor.
Yeah.
And then monitoring, of course. So once you get a pipeline like this up and running, you want to be able to monitor the health of it. And so in this view, I'm actually looking at Bigtable and the requests that are coming in to Bigtable over the past hour. And you can just get a view of a nice way to look at the performance of the right side of this pipeline, and we can see some interesting peaks and valleys that might be worthy of investigation. Like why do our read requests drop off so dramatically for periods of time, and why is that seems to correspond to the number of write requests dropping off? Wonder what happened there. Maybe our pipeline stalled. Maybe some piece of software fell over and then got restarted. Monitoring gives you the tools you need to go and start investigating these things.
Awesome. Well, very cool. Thank you so much. If this pipeline and the kind of the code that you used to build it is something you want to share with the rest of the world, we'd love to obviously share your GitHub repo and kind of wherever you want to publish it in the video description for the session. But want to thank you, Vince, very much for doing this with us. Really appreciate it. I feel like I learned a lot.
No, it's really good. It's really nice, and it can have so many use cases in the industry. Ad, for example. So yeah, it's a really good. Thank you very much, Vince.
Thanks, guys, for having me on. Really enjoyed talking to you guys today. Hope it was useful for everybody out there too.
I think so, and obviously, your credit to the specialist folks here, and if they're all as good as you, then obviously we should be having them talk to all of our customers.
Yeah.
They're better than me, thankfully.
All right. Well, I think both Michel and I find that difficult to believe, but I think we'll leave it at
Yes.
that. Vince, thank you so much. Thank you to everyone who tuned in today to watch us talk about some advanced topics in stream processing. Come back next week when Anthony and a few other folks will be talking about GCP use cases that are specific to the public sector, which is going to be a bit of a detour for us from our normal topics, but really interesting. I'll certainly be trying to tune in. Michel, thanks for being here.
Oh, thank you very much, Yuri.
All right.
You, Vince.
Folks.
Thanks, guys.
Yeah, thank you. Like, rate, subscribe.
Yeah.
If you found this live stream not by our Meetup group, please join our Meetup at meetup.com/GCPonline, where you can get in touch with us, suggest topics for other sessions.
Yes, exactly.
And
Add the topics you want to discuss, and we'll do our best to find the right expert to help you.
Yeah, absolutely. All right, folks, enjoy the rest of your week. We'll see you soon.
Bye, everyone.